So we're going to do an example of arranging words in this video. So this says how many 5-letter strings or words. Sometimes in math we use the word words, but it doesn't necessarily mean that it has to be an existing word. It could just be a string of letters. So when we're talking about strings of letters or words, we're talking about something in an arrangement. So we're going to use a permutation or the multiplication principle. Okay, and so we'll do that for these. So 5-letter strings. So here there's 1, 2, 3, 4, 5. So it's only asking us to arrange those letters. So this is one way, and we could write them all out, but we say there's 5 spots, and we're choosing 5 letters. So you have 5 choices for the first spot, 4, 3, 2, 1. We could also say 5P, 5. Out of the 5 letters, choose all 5. Or it goes all the way down to 1. This is also 5 factorial. So all of these would give you the same answer. 5P, 5. 120, or if you multiplied them out, you'd get 120. 5 factorial, 120. Okay, so there's 120 arrangements. So we wouldn't want to do that. Now in the last couple of videos, we had arrangements of just 3, which is 6, and you could write that out. But when we get up to 5, that's a lot more. Now this one will help you with an assignment question. It's too hard for the exam, but for an assignment, it's fine. Let's look at it, and then you can try the one on your assignment. This says 5-letter strings, but how many letters are here? 7. 1, 2, 3, 4, 5, 6, 7. So you're not arranging all 7. So we're not going to do the indistinguishable permutations that we did in a couple videos ago. That would be if you were arranging all 7, we would say 7 factorial, and then you divide by, if you remember, you divide by any duplicate. So there's 2 E's, and there's 2 T's, and this would be if you're arranging all 7. Now we're not doing that, we only want to arrange 5. So you actually have to think of the different, if they were all different letters, that would be fine. But since they have some repeats, we have to think about that. So let's write down the different cases. Case 1, so let's see, how many letters are there? There's an L, there's an E, but there's 2 of these. T, there's 2 of those. R and S, there's only 1 of each of these. So there's 5 different letters, but 2 E's and 2 T's, and we wouldn't be able to tell them apart if we put them. Let's say case 1 is all different letters. So if we were just choosing out of the different letters, we would have 5 choices for the first spot, 4, 3, 2, 1. 120 ways we can arrange those 5 letters. So what if case 2 was that the word that we're making has 2 E's in it? So let's say there are 2 E's in it, and that's indistinguishable, so we have to think about that. And then out of the other 1, 2, 3, 4 letters, how many would we want? Well, we want 5 letters altogether. There's 4 left. L, T, R, S. So we want to use both of these, right? 1, 2 of the letters, and then 1, 2, 3, 4, we want 3 of these, and 2 of these. Okay? So how would we look at that? This is actually a little bit more complicated. You have to count the arrangements of these, but the E's we don't want to count the arrangements. Okay, so how would this look? First we need to pick So let's write the 5 spots, 4, 5, and we want to pick 2 of these lines to have the E's on them. So let's place the E's first. So there's 5 spots, and we want to count how many ways we could put the E's. So just for example, we could put the E's in the first 2 spots and then have 3 other letters. We could put the E here and here. We could put the E here, here, and then keep counting. We could say blank, E, E, blank, blank. Right? We want to count that. So what we're doing is, it doesn't matter the order we pick the 2 lines for the E to go in because they're the same thing, but we want, so the order is not important. When order is not important, we're just picking 2 of the 5 lines, so we want to choose 2 of the 5 spots to place the E. So that would be 5, choose 2. 10. So if I had kept writing these, I would have found 10 ways that we could place the E's. Now, once we know there's 10 of these, we just need to figure out what each of them is. So let's suppose the E's are here. There's 4 letters left, so we have 4 choices, then 3, then 2 for the other 3 spots. 4 times 3 is 12, times 2 is 24. So the total is 5C2 times 4 times 3 times 2 is 24, because there's 10 ways and each of them has 24. Now that's for the 2 E's. How would it work for the 2 T's? Two T's, and then the other letters are L, E, R, S, and we want 3. So isn't it essentially the exact same thing as this? You would first have 10, and then for each of those 10, 24. Oh, thank you, that should be 240. And so this one is 240 as well. Case 1 was 120, each of these is 240. What would another case be? So we have all different letters here, no repeats. Then we have 2 E's, 2 T's. Case 4 would be, what about 2 E's and 2 T's? Okay, let's go to the next page for that. So let's think about what we're looking at. We have 5 spots and we want to put 2 E's on them, so let's just give an example, and 2 T's on one, and then we just have 1 left to choose. And we would choose either, what are the other letters? L, R, or S to go here. So we have 3 choices for that last spot. Okay, so I think there's lots of different ways to do this, but let's say if we were looking at just the L. So say the L was going in that last spot. Then we've got 5 letters, E, E, T, T, L, and we want to count the arrangements of these. So there's 5 letters, and then we divide by the 2 E's and the 2 T's. That's the indistinguishable permutations. That we did earlier. and then we would get our answer. So 5 factorial divided by 2 twice, so 30. 30 ways if the L was in that spot. So that's just taking these and rearranging them. L, R, same idea, 5 letters, but 2 E's and 2 L's, so 30. And the S, same thing again, 5 letters, 2 E's and 2 L's, 30. So case 4, or 30 times 3 is 90. Okay, so that's all the cases. So in total, the number of ways to choose 5 of those letters and rearrange them is, we had 120 up here, and then we had 240 twice, and then we had 90. So 690 total. Okay, so that's how I would do that question. I would break it down into the different situations and do it that way. One, two, three, four, five, six. So just to remind you, go back. Sometimes it's best to look at just a simple example at the end. If I were to arrange 1, 2, 3, 4, 5, 6 letters and want to count the number of ways to arrange that, how many 6-letter arrangements? And there's 6 letters, and they're all different. Then we would say 6 times 5 times 4 times 3 times 2 times 1, or 6 factorial. And how many 5-letter arrangements? Oh, okay. 5-letter arrangements. Oh, that spelling's terrible. So there's 6 letters, but we only want 5, but they are all different. We only want 5. 1, 2, 3, 4, 5. 6 choices. 5, 4, 3, 2. Actually, it'll be the same answer. What about how many 4-letter arrangements? Four lines, 6, 5, 4, 3, which we could say is 6p. The numbers go down. We're choosing 4 of those letters to arrange. Okay, and so on. And then if we had a word that had a repeating letter, 1, 2, 3, 4, 5, 6 letters, and we wanted 6-letter arrangements. So there's 6, it would be 6 factorial, the same as this one. The only difference is there's 2 E's, so we want to divide out 2 factorial. $360. Because every time you have the E and the E up here, when they're all different, it would be counting those as 2 ways. You put the E that way or flip them, and we want to divide out all of those 2. 5-letter arrangements. and that's when it becomes harder. So now we've got 5 letters, 6 to pick from, and we want 5, so we would do the different cases for that. Okay, so you could try that. Case 1, all different. One, two, three, four, five, six. There's 6. There's 2 E's, so that would just be taking W, E, K, L, and Y and counting how many arrangements those are. 5 letters, and we want to arrange them. They're all different. And case 2 would be to have 2 E's in it. So 1, 2, 3, 4, 5, but 2 of them are going to be E's, and so the other 3 are going to be chosen from the letters W, K, L, and Y. Okay, we'll do this on the next page. So again, we want to first choose where to put the 2 E's. So there are 5 spots, and we want to choose 2 of them. So there's 10 ways that we could choose 2 lines out of the 5. And then just write one example down, and then we've got 4 letters to pick from. So 4 times 3 times 2. 12 times 2 is 24. Same sort of scenario as last time. 10 times 24 is 240. And there is no case 3 because the only repeating letters were those 2. So here, all different, that could have 1 E in it. Here's 2 E's. We don't have enough letters if we take out the E's altogether, so there has to be at least 1 E. And so our total would be 360. Oh no, not 360. 5 factorial, case 1, 120, plus 240 is 360. Okay.